Okay, 11.1, we're going to work with a parametric equation, or parametric functions. Okay, what is a parametric function? There are two spots right before this chapter that deals with parametric. Chapter 1 is parametric and finding the derivative, which was in chapter 4. Under the chain rule, if you wanted to look under 4.1, parametric equations. I was just going to explain it to you anyway. A parametric equation has t as the independent variable and x and y as the dependent variable. So back in like chapter 1, x equals 3 plus t and y equals a negative 2t squared minus 4 is a parametric equation. It's made up of two equations, x in terms of t, y in terms of t. Instead of making an xy chart, you make a t-xy chart. All you do is you let time, t stands for time, like 1 minute, 2 minutes, I don't know, space car or whatever they're talking about in terms of time, rockets. And the time is 1. You're going to put 1 up into the x value to find the x value, and then you're going to plug 1 into the y value to find the y value. And the y value, let's make this a positive, I don't know why, but when t is 1, you get a negative 2, and so on. When t is 2, you get 5 for the x value, and when t is 2, you get 4 for the y value. This is called a parametric equation. Now, how do you find the derivative, which we skipped over in 4.1, but I'm just going to explain to you how to find the derivative, dy dx. The derivative is y prime over x prime. Another way to write it is dy dt divided by dx dt. It's the same thing. So how do you find the derivative? It's really quick. All you have to know is the y value goes on the top, the x value goes on the bottom, but you take the derivative of the top of the y value. What's the derivative of 2t squared minus 4? 4t divided by the derivative of x is 1, which is equal to 4t. So to find the derivative of a parametric equation, y prime over x prime, I just want to show you that dy, the derivative of y, this means the derivative of y in terms of t. This is the derivative of x in terms of t. And look what happens if you want to change the division sign to multiplication, flip the dx dt to dt over dx, and voila, the dt's go away, and what are you left with? dy over dx. So all of these stand for derivative of a parametric equation. Okay, now, so this was basically chapter 1, how to graph one, or how to find the values. 4.1 was to find the derivative. Now in 11.1, we're going to learn how to find the double derivative. So I'm going to go to another page, and basically in 11.1 we're going to learn two formulas. Formula for the double derivative. Remember, this is how you write double derivative. It's kind of weird. The 2 goes in between the d and the y, and then it goes after the x. This is the formula for a parametric equation. It's dy prime over dt over just dx dt. So to find the double derivative of a parametric equation, you have to find the derivative of the derivative, but not for dx dt. So I'm going to give you an example. You're going to let x equal t minus t squared. I'm going to let y equal t minus t cubed. So these are a parametric equation, x in terms of t, y in terms of t. And what I'm going to do is they're going to ask you to find the double derivative on the AP test. So the first thing I'm going to do is find the first derivative. And how do you find the first derivative? It's dy dx, or y prime over x prime, which makes sense. Y prime is 1 minus 3t squared. X prime is 1 minus 2t. So far, so good. We found the first derivative. Now, how do we find the second derivative? D squared y over dx squared is equal to, I'll write it down again, dy prime dt over dx dt. So, this is how you do it. I don't know why I keep writing this, but that's, okay, so you need to take the derivative of the y. Of the y prime, I mean. So, how do you find dy prime over dt? What you need to do is take this whole thing, and you need to find the derivative of that whole thing. And that's what's going to go on the top. So, let's do, okay, this whole thing, you're going to find the derivative of that whole thing, dy prime over dt. Okay, how do I explain this? You're finding the derivative of the y value of dt, which is that. So, I'm going to use the quotient rule, low d high minus high d low, all over low squared. So I'm going to go over here, and I'm just going to do this part right here. Low times the derivative of the high, which is negative 16, minus high times the derivative of the low, which is negative 2, all over low squared, which is equal to a negative 6t plus 12t squared plus 2 minus 16 squared, which is equal to, put these two together, you get 6t squared minus 6t plus 2 all over 1 minus 2t raised to the second power. Okay, that's what's going to go on the top. Oops. Divided by, you just take the derivative that you already found, which is just this. So you don't even have to find the derivative of that. You just leave it as 1 minus 2t. Final answer, 6t squared minus 6t plus 2 all over 1 minus 2t squared. This is like 1, so I can flip this. So really the final answer is 6t squared minus 6t plus 2 all over 1 minus 2t cubed. Final answer. So let's just go back and recap what we've learned. A parametric equation in Chapter 1 is x in terms of t, y in terms of t. On 4.1, we did not go over the parametric, how to find the derivative, because it was not on the AP AB test. But how do you find the derivative of a parametric equation? It's the derivative of y over the derivative of x, which isn't that difficult. But now, today, we learned how to find the double derivative. And to find the double derivative, you take the derivative of the whole dy dx. You take the derivative of the whole dy dx all over the derivative of dx over dt. So, here's the derivative right here. So I had to take the derivative of that using the quotient rule. which ended up being right here, and that's going to go on the top, all over just the derivative of x prime, which is 1 minus 2t, and then you just simplify. I'm only going to do one of those because you can practice this on your own. Okay, one other formula that we need to learn in 11.1 is the length of a curve. At the beginning of Calculus BC, Chapter 8 had the length of all the different types of curves. There was a formula to find the length of a curve. Well, you can find the length of a curve of a parametric equation also. You're going to integrate from a to b the square root of dx over dt squared plus dy over dt squared. If you look back on Chapter 8, I'm just going to look back on Chapter 8, and you're going to see the length of the curve on 8.4. Do you remember that the length of the curve in 8.4, you're going to integrate from a to b the square root of 1 plus dy dx squared? Do you remember that formula from 8.4? Well, it's very similar to that, except you don't just have one derivative, you have to take both of them in this formula. So I'm just going to erase this, or let's just leave it. Let's just leave it. So this was 8.4, but now we're doing the length of a curve of a parametric equation. So I'm just going to do one example, and that's about it. So here we go. We're going to let x equal the cosine, or if you like seeing it, isn't it really the cosine of t raised to the third power? It's the same thing. Let y equal the sine 3 to the third power t. From 0, which is less than or equal to t, which is less than or equal to 2 pi. This is our a to b, so keep that in mind. So, if I graph this, how do you graph this? I'm just going to tell you if you want to know how to graph in parametric. If you open up your calculator and you open up mode, and you look at your mode, fourth one down, there's a function button, and that's the y equals. If you look to the right of the function button, there's a PAR, which means parametric. So if you go down and arrow over to parametric and hit enter, and then you hit your y equals, where you want to plot this parametric equation, hit your y equals button, and you're going to notice now that your calculator does not just have a y, it has an x and a y. And when we can put those in, we could put 3 plus t in, and when you hit the variable button, the variable x doesn't show up anymore, the letter t shows up. So, again, you go under mode, you go under the fourth line, instead of function, you hit parametric. And that's how you switch your calculator from a function to a parametric. But we're not gonna do that. So, I just wanted to show you where it was on your graphing calculator. So, are you ready to find the length of a parametric equation? So, the first thing I need to do is find the derivative of dx dt, and I also have to find the derivative of dy dt. So that's my first thing. So, derivative of dx dt. Do you notice that I need to use the chain rule to do this because it's a power function? I'm going to put my 3 out in front, leave the inside alone, change my 3 to a 2. Then I also need to take the derivative of the inside. And the derivative of the inside is, what's the derivative of cosine? A negative sine. Okay, now I'm going to find the derivative of dy dt. Again, this is the same thing as the sine of t raised to the third power. I'm going to put the 3 out in front, leave the inside alone, change this to a 2, and find the derivative of sine, which is cosine of t. Okay, now, since I found the derivative of both of them, I'm just going to use my formula. I'm going to take the dx dt and I'm going to square it. I'm going to take my dy dt and I'm going to square it. I'm going to put it all under the square root from 0 to 2 pi. So this is how you find the length. We got to use a little bit of trigonometry. To find the length of an arc, we're going to go from 0 to 2 pi, which will give it that. I'm going to take the square root, and basically I'm just going to take all of this, I'm going to run out of room here, and I'm going to square it, and I'm going to take all of this, and I'm going to square it. So, all I'm going to do now is simplify all this, integrate from 0 to 2 pi. When you square this, I'm going to put the negative on out here so it's not there anymore. What's 3 cosine t sine t? A negative 3 times a negative 3 is a positive 9. And if I take this and square it, it's the cosine 4t. And if I take the sine, it'll be sine squared t. Okay, that's just for the first part. Right here is this. Plus, if I square everything in here, 3 squared is 9. I take the sine and I square it, which is sine 4t. And I take the cosine and I square it. So basically I squared everything. Now, I just have to simplify this from 0 to 2 pi. Do you notice that they both have something in common with each other? Do you notice that they both have a 9? They both have at least a cosine 2t. And they both have at least a sine squared t. And that's the GCF. So what I did was I took it out. Again, they both have a 9. They both have at least a cosine 2t. And they both have at least a sine squared t. So I took it out. It's called GCF. All I have left in this one then is just a cosine squared t. All I have left in this one is a sine squared t. And this is the most important formula in trigonometry. I hope you know that cosine squared t plus sine squared t equals something. I gave you a formula sheet at the beginning of the year for trig functions, and I think most of you know that cosine squared t plus sine squared t is 1. So 1 times that. So now we're down to 0 to pi times the square root. You know what? I'm not going to make it square root because we're left with just this. And the square root of 9 is 3. The square root of cosine squared t is cosine t. And the derivative of sine is sine t. So I took it out of the square root. And now all I have to do is integrate that. And when you integrate that, okay, let's finish this. Let's integrate this. How do you integrate this? You need to notice that this is the derivative of sine of t. U equals the sine of t. Did I forget my dt? Sorry. Let u equals the sine of t. Du dt, what's the derivative of sine? Cosine. Du divided by the cosine of t equals dt. The substitution property is a very, very, very important property. So I'm just going to substitute from 0 to 2 pi. I'm going to leave my 3. I'm going to leave my cosine t. Underneath sine of t, I'm not going to keep it sine of t. I'm going to put a u there. And in place of dt, I'm going to put du over the cosine of t. If I did it right, my cosine t goes away. I'm going to take my 3 and put it out in front. So I'm really integrating from 0 to 2 pi. U du. How do we integrate u du? I'm going to integrate it right now. This is to the first power, so you add 1, which is 2, and divide by 2 from 0 to 2 pi. Now all I'm going to do is put my sign back in there. And my final answer is going to equal 6. How did I get 6? I'm going to draw myself a picture of 1, 0 and negative 1, 0. And I'm going to put 2t in first. When I put in 2t, I get, 2t, I'm going to put 1 in. 2t and 0 are exactly the same. So if I plug the sine squared t of 2t, which is 1, and we're going to get 3 halves. And then when you minus, when you plug 0 in, okay, I want to finish this. No, you don't get 6 when you plug that in, but everybody look on, everybody look on page 539, and just read it with me. Measuring a parametric curve. We're going to find the length of an asteroid. It's on page 539. I'll give you time to find 539. Okay, so we're finding the length of this asteroid. To the left is the picture of the asteroid in 11.5 on the left-hand side. Do you notice that it's all 4 symmetrical? So basically, if you look down below, you're not integrating from 0 to 2 pi. You're really only integrating from 0 to pi over 2, which is up here. And when you do that, you get 3 halves. But then you have to multiply it by 4, because if you look at the picture, it's symmetrical on all 4 quadrants, and that's how they get the 6. So if you read through there, it'll explain how they got 6. Because they figured out that it was 3 halves. This is probably a 5 question because of the hardness at the end of comprehending the symmetrical. That is all for 11.1. I will assign you homework now.